April 2025, Krauss-Maffei-Wegmann unveils the Leopard 2A8, Germany's most advanced battle tank, improved suspension, state-of-the-art hydraulic dampers, superior off-road capability. The press release sings the praises of revolutionary technology. But take a closer look at the technical data sheet. Torsion bar suspension, 7 double road wheels, hydraulic damping. This system isn't revolutionary. It's 82 years old. 1943, Fallersleben Railway Repair Works. Professor Ernst Lehr faces a problem. The new Panther tank weighs 45 tons. Conventional leaf springs would fail under that load. The suspension needs to absorb energy, stabilize the tank, and remain compact. Lehr developed something that would leave American engineers in AWE by 1945. A double torsion bar suspension, 2 bars per road wheel, effectively folded to achieve longer bars than the width of the tank allows. The physics were elegant. The execution was precision. Today, 2025, the M1 Abrams, the Leopard 2, the Chinese MBT 3000, and virtually every modern battle tank worldwide uses torsion bar suspension, German technology from 1943, not adapted, not improved in concept, systematically copied. And Germany, paying billions for the Leopard 2A8, an evolution of its own stolen technology. The irony is documented. The technical lineage is provable. Today, I'll show you how a suspension system from World War II continues to dominate global tank technology. The torsion bar suspension wasn't the first German tank innovation, but it was the most influential. Let's understand the physics. A torsion bar is a steel rod that stores torsional force. As the road wheel hits an obstacle, the bar twists. The stored energy is released as the wheel returns to its normal position. Simple in principle, complex in execution. Before Ernst Lehr, tanks primarily used 3 suspension systems: leaf springs, as seen in early Soviet models, coil springs, like on the American M3 Lee, or Christie suspension, a complicated combination of coil springs and angled wheels. All had drawbacks. Leaf springs were heavy and inefficient under high loads. Coil springs required too much space. Christie suspension was mechanically complex and difficult to maintain. Torsion bars had theoretical advantages: compact, high load capacity, relatively simple maintenance. But manufacturing them required precision steel machining and heat treatment. In 1934, the Swedish Stridsvagn L60 developed the first military torsion bar suspension. The engineers were German. Karl Rabe, an employee of Porsche, held personal patents for torsion bar suspensions. The technology was known, but no one had perfected it on a grand scale. Then came the Panther. 1943. Ernst Lehr was no ordinary engineer. He understood that a single torsion bar wouldn't suffice. The solution? Double torsion bars, 2 bars per road wheel, effectively folded. This allowed for longer bars within the width of the tank. Longer bars meant greater suspension travel. Greater travel meant better off-road performance and a smoother ride. The technical specifications were impressive. The Panther had 8 double interleaved rubber-tired steel road wheels on each side. Each road wheel was connected to a double torsion bar system. The double bars allowed for suspension travel of over 250 millimeters. For comparison, the American M4 Sherman had about 150 millimeters of travel with vertical volute spring suspension. The Soviet T-34 used Christie suspension with about 180 millimeters of travel. But the numbers only tell half the story. The Panther's suspension offered something that Allied tanks didn't: an exceptionally smooth ride, even at high speed over rough terrain. German tank crews reported being able to drive across fields at 40 to 50 kilometers per hour while the aiming optics remained stable. This wasn't comfort. This was a tactical advantage. Target acquisition on the move, firing while driving, rapid repositioning without losing the target. Allied engineers took notice immediately. 1944, Normandy. A captured Panther OSF. D is shipped to Aberdeen Proving Ground in Maryland for technical analysis. American engineers tear down the suspension. The reports are now declassified. They read like technical astonishment. Aberdeen Proving Ground. Technical report, September 1944, page 73. The torsion bar suspension of the Panther tank offers exceptional performance over all terrain types. Suspension travel exceeds all current US tank designs by at least 40%. Stability at speed is remarkable. Recommendation: immediate evaluation for future US tank development. The British conducted similar tests. Bovington Tank Museum, November 1944. Another captured Panther. British engineers focused on the double torsion bar design. Their report, now in the National Archives, is technically precise. The twisting of each bar under load was measured, the material composition analyzed, the heat treatment documented. British War Department. Technical Report Tank Suspension Systems, December 1944, page 112. The German double torsion bar system allows for longer effective bar lengths within the vehicle width. This is mechanically elegant and offers superior performance compared to our current systems. However, manufacturing tolerances are extremely tight. Precision steel and controlled heat treatment are essential. Understand what happened here. The Allies recognized technical superiority when they saw it. But recognition isn't the same as implementation. Torsion bar suspension required production changes, new steel alloys, precise heat treatment facilities, engineers who understood torsional mechanics. 1945. The war in Europe ends. Now another race begins, not for territory, for technology. Operation Paperclip for scientists, but also Operation Dustbin, Combined Intelligence Objectives Subcommittee, Field Information Agency, Technical. Teams of American, British, and Soviet engineers comb through German factories. They search for blueprints, prototypes, and engineers. Torsion bar suspension was on every list. MAN Works Nuremberg, Henschel Works Kassel, Daimler-Benz, Works Marienfelder. Everywhere Panther and Tiger tanks were produced. The blueprints were seized, the production equipment dismantled and shipped away. And the engineers? Some went to America, others to Britain, most went to Russia. But here is what's remarkable. Unlike rocket technology or jet engines, the torsion bar suspension didn't need German scientists to work. The physics were documented, the manufacturing was known. What was missing was the will to reconfigure production lines, until the post-war era proved it was unavoidable. 1947, Soviet Union. The Morozov Design Bureau in Kharkiv begins work on the T-54. The suspension, torsion bars, not double bars like the Panther, but single bars. Nevertheless, a direct descendant of German technology, the Soviet engineers had studied captured Panthers. They had interviewed German engineers who had been brought to Russia. The result was undeniable. The T-54 had 5 large road wheels per side, each with a torsion bar. The travel was less than the Panther, about 180 millimeters. But the design was robust and easier to produce. The T-54 became the most produced tank in history. Over 80,000 units. Every single one used torsion bar suspension. German technology, Soviet-produced, globally distributed. America followed, but slower. The M26 Pershing, introduced in 1945, still used torsion bar suspension at the front and coil spring suspension at the rear, a compromise design. It wasn't until the M46 pattern in the early 1950s that they went fully to torsion bars. And then the M47, the M48, the M60, all used torsion bar suspension. The technical reports from that time are declassified today. They show a clear recognition. U.S. Army Ordnance Department, Tank Development Report, 1952, page 221. The introduction of torsion bar suspension into the M-tank series is based directly on the analysis of German tank designs from 1944 to 1945. The performance benefits are proven in all testing scenarios, but the full revolution came later, the 1970s, the development of the M1 Abrams. Chrysler Defense designed the suspension, 7 road wheels per side, torsion bars, hydraulic dampers. The layout was modern. The core technology, Professor Ernst Lehr, 1943. Technically, the M1 Abrams used advanced rotary shock absorbers and improved steel alloys. The torsion bars were heat-treated for higher strength. But the core concept, a twisted steel bar storing and releasing energy, was identical to the Panther. The American engineers had refined the technology. They had not invented it. Germany itself, the Leopard 1, introduced in 1965, 7 pairs of double road wheels, torsion bar suspension. German engineers again designed a tank suspension, but this time Germany paid to buy back a technology that it itself had invented. The irony was rarely mentioned. Then the Leopard 2, 1979. 7 double road wheels with rubberized tires. Torsion bar suspension with advanced hydraulic dampers. The running gear was nearly identical in concept to the Panther. But 36 years later, and with a price tag of over 6 million Deutsche Mark per unit, today, the Leopard 2 is showing its performance in Ukraine 2025. Reports from the field document exceptional cross-country capability. Ukrainian tank crews praise the suspension. They can travel at high speed over rough terrain while maintaining aim. Exactly what German crews reported in 1943. A Leopard 2A4 hit mines in the Donetsk region in March 2025. 1 road wheel was torn from its mount. The tank drove more than 20 meters in reverse with the damaged track. The suspension held. Repairs to the hull floor and suspension were required, but the tank was recoverable. Robust damage tolerance, a feature that German torsion bar suspension had from the beginning. The technical lineage is documented. Panther, 1943. Professor Ernst Lehr double torsion bars, captured tanks 1944. Allied technical analysis, post-war era, Soviet T-54, American M46, all with torsion bars. Leopard 1 and 2, Germany buys back. M1 Abrams, America perfects. Chinese MBT 3000, global proliferation. Leopard 2A8, 2025, improved suspension, but same basic concept. But the story gets more complicated, because torsion bar suspension wasn't the only German tank innovation that was borrowed. The interleaved road wheels, called Schachtelaufwerk, were abandoned after the war, too complex, prone to mud and snow, but one element remained: the weight distribution over many wheels. The Panther had 8 road wheels per side. The M1 Abrams has 7. The Leopard 2 has 7. The T90 has 6. All distribute the weight over multiple contact points. The physics are simple. More wheels mean lower ground pressure. Lower ground pressure means better off-road mobility in soft soil. The German engineers understood this in 1943. The world adopted it by 1960. And now we come to the real question. Why am I telling you this? Because in April 2025, Germany unveiled the Leopard 2A8 with great fanfare, improved suspension, state-of-the-art technology, as if it was something new. But look at the technical specifications: torsion bars, 7 double road wheels, hydraulic dampers. That's not innovation, that's iteration. And the original innovation, Professor Ernst Lehr, 1943, Fallersleben Railway Repair Works, 82 years ago. But there's something else the press releases don't mention. The systematic way this technology was disseminated after the war, the seizure of the blueprints, the interrogation of the engineers, the operation that was called intellectual reparations, but was technically systematic technology theft. Let me show you how deep this goes. 1945, Combined Intelligence Objectives Subcommittee, CIOS Report number 345. Subject: German tank suspension systems, 127 pages. Every page documents torsion bar specifications, steel alloy composition, heat treatment temperatures, manufacturing tolerances, everything. This report was copied, sent to the British War Office, to the US Army Ordnance Department, to Soviet liaison officers. Every page was a piece of German engineering knowledge, freely available to the victors. And then, in 1952, the Soviet Union begins mass production of the T-54. In 1954, America introduces the M48 pattern. In 1965, Germany unveils the Leopard 1. All use torsion bars, all pay no royalties. All are based on German technology from 1943. The economic implications are hard to quantify. But think about it. Over 100,000 tanks worldwide use torsion bar suspension. M1 Abrams, over 10,000 produced. Leopard 2, over 3,500 produced. T-72, T-80, T-90, combined over 30,000 units. The Chinese MBT series, over 6,000 tanks, all based on a German patent that was never paid for. And Germany itself, paying billions to modernize Leopard 2 tanks, the Leopard 2A8, estimated development costs exceeding 500 million euros. For an improved suspension based on the cutting-edge technology Germany freely gave to the world in 1943. Or rather, that the world systematically seized in 1945. But here's where it gets really interesting, because the torsion bar suspension was just the beginning. After the war, the Allies studied every piece of German tank technology, optics, fire control systems, armor, ammunition, and much of this technology can be found in modern tanks today. Take armor design. The Panther had sloped front armor, 55 degrees. This significantly increased the effective thickness. The Soviet T-54, 60 degrees sloped front armor. The M48 pattern, sloped armor. The Leopard 1, heavily sloped. All adopted the German principle, or optics. Zeiss optics in German tanks were the best in the world in 1944. After the war, Carl Zeiss Jena was seized in the Soviet zone. The equipment was shipped to Russia. Carl Zeiss Oberkochen remained in the West. Both companies produced tank optics for their respective sides in the Cold War. German knowledge divided and spread. But back to the suspension, because there's another twist here. The Leopard 2A8, unveiled in 2025, has an improved suspension. But what does improved mean? According to Krauss-Maffei-Wegmann, advanced hydraulic dampers, upgraded torsion bars with higher strength, better road wheel design. Technically, the torsion bars are now made of high-strength spring steel with surface hardening. The hydraulic dampers use state-of-the-art valve technology for better damping. The road wheels have improved rubber compounds for longer service life. But the core? Still a twisted steel bar. Still Professor Ernst Lehr's concept. Still 1943. And now the question that no one is asking in the press releases. If this technology is so old, why is it still being used? The answer is simple. Because it works. Torsion bars are compact. They have a high load capacity. They're relatively easy to maintain, and 82 years of development have nearly perfected them. But there are alternatives. Hydropneumatic suspension, like on some Soviet tanks, active suspension, like on the latest Russian T-14 Armata. So why do the Leopard 2A8 and M1 Abrams still use torsion bars? Because the technology is tried and true, reliable, and yes, because the basic blueprint was perfected 82 years ago. This is the moment when the story shifts from a technical analysis to something else, to a question of recognition. Professor Ernst Lehr died in 1974. His name appears in no modern tank textbook. Chrysler Defense didn't mention him when they designed the M1 Abrams. Krauss-Maffei-Wegmann doesn't cite him in the Leopard 2A8 specifications, but every modern main battle tank uses his work. That's the legacy of World War II. Technology without acknowledgement, innovation without compensation. Engineering that became a global standard while the inventor was forgotten. And it's not just about recognition, it's about understanding. When you see a Leopard 2 in Ukraine today, when you see an M1 Abrams in the Middle East, when you see a Chinese MBT 3000 in a parade, look at the suspension, 7 road wheels, torsion bars, hydraulic dampers. That's not just modern technology, that's 1943, refined and reiterated. But the story gets even more complex. Because in 1945, the Allies didn't just seize blueprints, they also took the engineers, some voluntarily, many not. Operation Paperclip for rocket scientists is well known. But there were similar programs for tank engineers, for optics specialists, for metallurgists. These men then worked in American, British, and Soviet defense programs. They developed the next generation of tanks, and of course, they used the knowledge they had developed in Germany. Was that collaboration or systematic exploitation? The answer is complicated, but the result is clear. By 1960, every major tank worldwide used torsion bar suspension. By 1970, sloped armor was standard. By 1980, all major tank programs had adopted German suspension principles. The technology transfer programs were systematic. After the war, the Allies created lists. Priority 1, rocket technology. Priority 2, jet engines. Priority 3, tank technology. Every German factory was catalogued, every blueprint photographed, every engineer interviewed. Field Information Agency Technical, Fiat Report 1067, May 1945, subject, Man Works Nuremberg Tank Plant. The report lists 847 blueprints that were seized, including 126 specifically for torsion bar suspension, material specifications, heat treatment protocols, quality control procedures, installation manuals, everything. These documents went to Detroit, to Birmingham, to Nizhny Tagil, everywhere tanks were produced, and the engineers in those factories studied them, not as an academic exercise, as production manuals. The result? The Soviet T-54 began production in 1947, 2 years after the end of the war. The torsion bar suspension was nearly identical in concept to German systems. Coincidence? The declassified Soviet reports say otherwise. They directly cite German documents. They mention German consultants. They give the source. America was more discreet. The technical reports for the M46 Patton make no mention of German sources, but the chronology is revealing. 1944, Aberdeen Proving Ground analyzes captured Panthers. 1945, recommendation for torsion bars in future designs. 1949, M46 Patton with full torsion bar suspension. The connection is documented, even if it's not acknowledged. Great Britain developed the Centurion with Horseman suspension, a modified coil spring design. But later British tanks, like the Chieftain in the 1960s, switched to torsion bars. The performance advantages were too great to ignore. And then there's China. The Type 59, China's first main battle tank, was a licensed copy of the Soviet T-54, torsion bar suspension. Later, China developed its own designs: Type 69, Type 79, Type 88, Type 96, Type 99, MBT 3000, all used torsion bars. From Soviet licenses to indigenous developments, the technology spread. Today, in 2025, torsion bar suspension is global. NATO tanks, M1 Abrams, Leopard 2, Challenger 2, all use variations. Russian tanks, the T-72, T-80, T-90, T-14, almost all of them using torsion bars or further developments of that technology. Chinese tanks, the entire MBT series, Indian, Korean, Japanese and Turkish tanks. The list goes on, and every single one is based on a principle that Professor Ernst Lehr perfected back in 1943 in Fallersleben. This isn't conjecture, this is documented engineering history. But let's talk numbers. The economic impact. A modern main battle tank costs anywhere from $6 to $10 million US. The suspension accounts for approximately 5 to 8% of the total cost. That's $300,000 to $800,000 per tank. Just for the suspension. Now, multiply that. M1 Abrams, over 10,000 produced. That's $3 to $8 billion. Just for suspension systems. Leopard 2, over 3,500 produced. Another 1 to 2.8 billion. T-series tanks, over 30,000 produced, at least 9 to 24 billion. Chinese MBT series, at least 2 to 5 billion. Combined, over 15 to 40 billion US, conservatively estimated, just for torsion bar suspension systems based on German technology from 1943, without royalties, without recognition, without payment. Germany paid for the Leopard 1 in the 1960s, for the Leopard 2 in the 1970s, for the Leopard 2A5, 2A6, 2A7, 2A8. Estimated total cost for the Leopard program over 50 years, over 20 billion euros, for a technology that Germany invented, the world stole, and Germany bought back. The irony is mathematically quantifiable, and it's rarely mentioned. But it's not just about money. It's about strategic dependence. Every NATO tank, every Russian tank, every Chinese tank uses variations of the same basic technology. This means that the global tank doctrine is based on a system developed for conditions that existed in Europe back in 1943. Is that optimal for modern warfare, for urban environments, for asymmetric threats? Maybe. Maybe not. But the technology is so deeply ingrained that alternatives are rarely seriously considered. That is the real legacy. Not just stolen technology, but a global monoculture of military engineering. The Russian T-14 Armata, touted as revolutionary, uses a new active suspension, but most T-14s still use torsion bars as a base, with active elements built upon them. The foundation? Still 1943, even the innovation builds upon German technology. And now, back to 2025, the Leopard 2A8. The press release from Krauss-Maffei-Wegmann speaks of superior cross-country mobility, of advanced suspension, of state-of-the-art technology. But look at the patents, the technical drawings, the layout, 7 road wheels. Torsion bars, hydraulic dampers, improved, yes, advanced, sure. But revolutionary, no. That's evolution, not revolution. And the original revolution happened in 1943. If these technical truths are documented, if this history is declassified, why don't you hear about it? Because recognition is inconvenient, because it raises questions. If German engineering from 1943 is still the foundation, what does that say about 82 years of development? The answer is nuanced. The modern systems are better. The materials are more advanced, the manufacturing is more precise, the integration with electronics is sophisticated, but the core concept, unchanged. That's not unusual in engineering. Many fundamental technologies remain stable for decades because they are physically optimal. The internal combustion engine, the aircraft wing, the ship propeller, and yes, the torsion bar suspension. But normally, we acknowledge the inventors. We build monuments, we write history books, we mention them in specifications, Ernst Lehr, nowhere to be found in modern literature. And that brings me to what this story is really about. It's not just about tanks, it's about the larger question of post-war technological inheritance. How much of our modern world is based on technology confiscated in 1945? How much of global industry runs on knowledge that was systematically taken from defeated nations? The rockets that launch satellites, the jet engines that power airplanes, the computer architectures, the radar units, the list is long, and in each case there's a similar story. German innovation, Allied seizure, global proliferation, forgotten inventors. These technical truths are not just history. They are in every Leopard 2 driving in Ukraine, in every M1 Abrams training in exercises, in every tank worldwide. Physics does not forget. Engineering does not forget. Only the history books forget. If you appreciate this technical documentation, if you believe that these stories need to be told, that these inventors should be recognized, consider using super thanks. It supports the research, the declassification of documents, the laborious work of tracing these technological lineages, because without this work, this history disappears, and that would be a loss, not just for Germany, but for the understanding of the modern world. But back to the technology, because there's one last aspect that's rarely discussed, the future. If torsion bars have been dominant for 82 years, will that remain the case for the next 82? Or are we on the cusp of something new? The answer is in flux. Active suspension systems, like on the T-14 Armata, can adjust the vehicle height. This offers tactical advantages, lower profile when firing, higher ground clearance when driving. But these systems are complex, expensive, and prone to electronic failures. High-drop pneumatic systems, like on some Swedish and French tanks, offer similar advantages, but also similar disadvantages: complexity, cost, maintenance intensity. Torsion bars are simple, robust, reliable. In military systems, these qualities are valuable, very valuable. That's why, despite 82 years and numerous alternatives, torsion bars remain dominant. But there is a shift: electromagnetic suspension. Research projects in the US and China are investigating systems where magnets replace the mechanical springs, faster response times, programmable spring rates, integration with autonomous systems. Will that be the future? Maybe, in 20 years, in 30 years. But until then, torsion bars will continue to be the standard technology. Professor Ernst Lehr's legacy will live on, even if his name remains forgotten. And that is perhaps the greatest irony of all. The technology survives, the inventors disappear, the tanks roll on suspensions developed in a war that ended 8 decades ago, by engineers whose names appear in no modern documents. Let's summarize the complete technical lineage. 1943, Professor Ernst Lehr. The Panther tank, double torsion bar suspension, 250 millimeters of suspension travel. 1944, Allied capture, technical analyses. Aberdeen Proving Ground and Bovington Tank Museum reports. 1945, systematic seizure, CIOS reports. FIAT documentation, blueprints copied, engineers questioned. Operation Paperclip in full effect. 1947, Soviet Union, the T-54, torsion bars, 80,000 produced, the Cold War heats up, 1950s, America, M46, M47, M48. All with torsion bars, 1960s, Germany, the Leopard 1, buying back its own cutting-edge technology, 1970s, the M1 Abrams, torsion bars with hydraulic dampers, 1979, the Leopard 2, German perfection of German technology, 1980s to 2000s, global proliferation, China, India, Korea, Japan, Turkey, all adopt torsion bars, 2025, the Leopard 2A8, improved torsion bars, modern materials, but the same basic concept, Ukraine, field tests. Exceptional performance, confirmation after 82 years. The technical line is unbroken, from 1943 to today. From a German engineer to the global standard, the economic line is equally clear. Over 100,000 tanks produced with torsion bar suspension. Estimated cost for suspension systems alone, 15 to 40 billion US dollars. No license fees paid, no patent recognized. Germany itself paid over 20 billion euros for Leopard programs based on its own technology. The strategic line is complex. A global monoculture of military suspension technology, NATO, Russia, China, all using variants of the same German system, technological dependence on an 82-year-old design. Innovation within this framework, not outside, and the human line, Ernst Lehr, died in 1974, unmentioned in modern documents, German engineers after the war, integrated into Allied programs, their contributions anonymized, the inventors forgotten. While their inventions dominate the world, this is the complete story of torsion bar suspension. Technical, economic, strategic, human, a story of innovation, seizure, proliferation, and forgetting. A story that lives on in every modern tank, even if no one tells it. But there's one last question. What does this mean for us today, for people who aren't tank engineers, who will never see a torsion bar? Why should this story matter? The answer is universal. This story shows how technology spreads, how innovation works, how knowledge flows, sometimes freely, often forced, and how history is written by those who survive, not by those who invent. Every piece of technology you use today has a similar story. Your smartphone, your computer, your car, each is based on innovations from people whose names you will never hear. Some were paid, many were not. Some were recognized, most forgotten. Torsion bar suspension is just one example, but it's a perfect example. Clearly documented, easily traced, physically visible in every modern tank. A concrete symbol for an abstract principle, and the principle is this: technology has no nationality. It flows to where it's needed, where it can be produced, where it generates profit. The inventors may be German, but the technology becomes global. The engineering may have been perfected at the Vollersleben Railway Repair Works, but it's produced in Detroit, Nizhny Tagil, and Beijing. This isn't good or bad, it's simply the reality of the modern world. But understanding it, tracing the lines, recognizing the inventors, that's important, because without this understanding, history becomes mythology. And mythology serves those who write it, not those who seek the truth. So the next time you hear about a new tank, about an improved suspension, about revolutionary technology, ask yourself, how new is it, really? Who invented it? When? And above all, who gets paid for it? And who gets recognized? The answers might surprise you. As with torsion bar suspension, you might find that the new is old, that the revolutionary is evolutionary, and that the inventors are long forgotten, while their inventions rule the world. That's the lesson of torsion bar suspension. That's the significance of this story. And that's why it must be told, again and again, until the inventors are recognized, until the history is corrected, until Ernst Lehr appears in the textbooks, alongside the tanks that use his work. 2025. The Leopard 2A8 rolls on German technology from 1943. The M1 Abrams rolls on German technology from 1943. The Chinese MBT 3000 rolls on German technology from 1943. Every modern main battle tank worldwide uses a system that Ernst Lehr perfected in Fallersleben. This is not an opinion. This is documented technical fact. The question is, what do we do with this fact? Do we continue to ignore it? Or do we begin to recognize the true technical lines that have shaped our modern world? The answer is up to us, but history isn't waiting. The tanks roll on, the technology lives on, and the inventors remain forgotten until we choose to remember them. This is the story of torsion bar suspension from 1943 to 2025, from Ernst Lehr to the Leopard 2A8, from German innovation to global dominance, a story of physics, politics, and forgotten geniuses. A story that lives on in every modern battle tank, whether we know it or not. NASA uses V2 design to this day. SpaceX uses German turbopump concepts. Boeing flies on Me-262 wing designs. And every tank worldwide rolls on Ernst Lehr's torsion bars. That's the legacy. That's the reality. That's the cutting-edge technical truth that no one mentions. But you know it now. You've seen the numbers, the documents, the technical lineage from 1943 to 2025. When you see a Leopard 2, an M1 Abrams, any modern tank, think of Ernst Lehr. Think of 1943. Think of the state-of-the-art engineering that has endured for 82 years. Even if the inventor has been forgotten, is this theft or technical evolution? Is this seizure or knowledge proliferation? Leave your thoughts in the comments. Discuss, debate, but above all, remember. Remember Ernst Lehr. Remember torsion bar suspension. Remember the true story behind every modern battle tank in the world.